So we know we need to use pointers in order to modify this swap function and make it do the job that we initially intended for it to be able to do. Okay, so let's see how we are going to use them and what are the implications. Instead of passing, well, the first thing to understand is that I can pass only values, okay? So to functions. So no matter what I write here, I am going to have expressions, I'm going to have more or less complex expression for the parameters, which are going to result in a value. And this is this value which is going to be passed to my functions. So the way that we pretty much successfully emulate passing parameters by references in a language which allows you only to pass on the program execution stack values is to pass a value which is going to represent the address at which the variables we want our function to be able to operate on are located. So this is the first thing that we do here. We pass as parameter number 1 the address of the variable x, as parameter number 2 the address of variable y. Of course, if I try to compile right now, well, the compiler is not going to be exactly happy about this. The deal here is it's pretty much telling me like I'm trying to pass an address of a variable of type integer, okay, so a pointer on int. I'm trying to pass a pointer on int value here where I expect an integer. Well, an int is not the same thing as a pointer on int. Okay, so I cannot simply just put an ampersand here and pass the address of those variables. And this is where we start to get away from the models that you have been already playing with in Java, for example, in C++ as well. In C++, you will find the same idea of the language passes only by value, and we have pointers to try to alleviate the solution. But we have also something called references in C++, which use, unfortunately, also the ampersand character as syntax. So when you look at this and you come from a C++ background, maybe you're going to get confused and think that we're talking about references. We are not talking about references. We are just using basic pointers. When you come from a Java background, you may not understand why we have to do this, okay? Well, Java has the same pretty much complication that the ones we're talking about here. Simply put, Java is a rather elegant way to simplify things. Java only states that when you are passing parameters to methods which are primitive Java data types, such as int, double, etc., those are always passed by value. Every time you are passing something which is an object, the object is passed automatically by reference. So you don't have a choice, really, in Java. Okay, there are two rules, one that apply to the Java primitive data type, one that applies to, well, everything else, okay, references to object. Here, we are at a much lower level again, and you have control about whether you want to pass a primitive data type such an int value, or just about anything, actually, by value, or by reference, okay? We'll see that there is one exception to this rule, the exception being arrays. Arrays in the C language, no matter what they are of, okay, an array of int, an array of double, an array of something much more complicated, is going to always be passed by reference. But we are going to get to that as we delve more in detail about pointers, okay? For now, we're still trying to convert this code into something that would actually, you know, do the job that we intended it to do to start off with. So we just realized that we need to pass actually pointers on int. Okay, we need our function to expect the address of an int variable and the address of another int variable as parameter instead of the values contained into those variables. And that makes sense because we want the function to pretty much operate on the variable x and y, not the values inside of them, which are 42 and 99. Okay, so that changes a couple of things. Okay, now the modification that I've done while I was talking was to declare the parameter as pointers on int, okay, as such. And now I need to use them as what they are, pointer on int. Okay, that means that when I want to display here the values, I'm not going to be so much interested in displaying the values of the pointers, that is the address of the variable they point to, but I want to display pretty much what those variables contain. Okay, so 1 and 2 are now pointers on the variable X and Y. Okay, and you see how the manipulation, the direct manipulation of memory address allow us to transcend the limitation of scope of variables and the fact that 1, 2, and X and Y live in different activation record. Okay, I can pass a value to the swap function invocation. This value is an address. Now inside of 1, for example, I have the address of the variable X, which means I can operate on it. Okay, now of course I'm trying to swap the values. So I'm going to dereference all those pointers. Okay. Let's compile real quick to make sure there are no syntactical error, and let's run it to see if it's doing what we expect it to do. Hit any key to start. So we start with 42 and 99 in the main. Okay, nothing new. That's good. When I call my function, the first printf tells me that 1 is pointing to an int variable containing 42. Well, that's good because 1 is supposed to point on x, so that's good. 2 is pointing to y, which contains 99. So okay, so far so good again. After I'm done here doing my permutation, 1 is pointing now to a variable, an int variable containing 99. So we are hoping that now x, contains 99, except if we did something really wrong. And 2 points to an int variable containing 42. So we are hoping that y contains 42. We return from our swap function invocation. All right, we are back in the main. We display x and y again, and now you can see that the swap function has been modifying actually the variable x and y.